Now that we know that at least one predictor is significant, we always have to test for individual regression coefficients. In other words, instead of having an overall test of is there something significant, we can test the individual predictors. So for example, we can test the significance, the partial significance for the size of home, and we can see the null and alternative. And we can test for the age, null and alternative. So those test statistics are the t statistics because those are partial tests. And you can see that these are based on the parameter estimate minus 0, which basically we just leave it like that, divided by the standard error of that estimate. Let me show you what I mean with this. The estimate for square footage is 0.04. We just want to know if this is statistically significant. So we have this value, this estimate. This is the standard error of that estimate. So if we divide this estimate by the standard error, beta 1 hat over s of beta 1 hat, we get a 6. That value is a t statistic. So t statistic with n minus k plus 1 degrees of freedom. So if we want to just test that, we find that it is 6 standard errors away from 0. So if we wanted to compute that p-value, then we just have to test basically from a table that contains the t statistic. We just want to see what 6 is in terms of the degrees of freedom, which is 39. And we will find that that's very far away. A t statistic is very similar to the normal distribution, so all the values close to, between minus 3 and 3. So 6 is a little far away from 0, so we find that it is statistically far away. So square footage is, we can find that we reject this null hypothesis in favor of the alternative. Beta 1 is not equal to 0. We find enough evidence to tell us that. For house age, the next test here, we can see that the estimate minus 0.8 divided by the standard errors minus 1.359, which is, it's a value close to 0 statistically in terms of the t distribution. So this is not statistically significant. So in other words, the partial test tells you, given that square footage is in the model, house age is not statistically significant. What that means really is not that house age is not important. It's just that in the presence of these other variable, square footage, house age does not seem to contribute. So we find that if you have square footage in the model, then there's no reason that, you might not need, you don't need to have this other house age variable. And let me explain a little bit further. I'm gonna add a line of code here, and then I'm just gonna copy and paste the code so you can see it better. Well, let me just write it here. So I'm just gonna create just a regression with house age. And I'm gonna just let me copy and paste all of these so that I can copy exactly the variable names. So I'm just gonna copy this and get the summary and scroll down so you can see these better. And basically I just forgot exactly where we were, but let's put it here. This is it. So I'm just gonna call this regression 1, and I'm not gonna include the other predictor. I'm just gonna have house age by its own, and I'm gonna run that so you can see these. And you can see that house age is significant at a 5% alpha level. So really what we are doing in this partial test is seeing the contribution of house age given that square footage is in the model. So that's why we call this partial, because it's not telling you the contribution of house age and whether it is significant, but the contribution of house age in the presence of square footage. House age is significant on its own at a 5% alpha level, but given square footage, what this is telling you, well, the partial contribution of this is not that much given the square footage is in the model.